A traffic alert and collision avoidance system, TCAS, provides the crew with traffic information and warnings of potential conflicts, with avoidance instructions. TCAS only detects and indicates other traffic equipped with a transponder. There are two different TCAS types. TCAS 1 provides intruder position indication only, called Traffic Advisories, TA, to assist the pilot in visually locating the intruder aircraft. TCAS 2 provides TA and avoidance maneuver information in a vertical direction only, called Resolution Advisories, RA, in order to avoid conflicting traffic and maintain a safe separation. TCAS 2 provides coordinated maneuvers with surrounding TCAS 2 equipped aircraft. The TCAS 2 is an independent airborne system which operates without support from air traffic control ground stations. It periodically interrogates the intruder transponders in the vicinity, computes their trajectories, and constantly determines their potential threat. Depending on the threat potential, the system provides TAs and RAs. The alerts are given using oral warning and display information. To evaluate the threat potential, the system divides the space around TCAS 2 equipped aircraft into 5 volumes. Intruders detected outside the blue envelope are known as other intruders. This detection can happen as far as 30 to 40 nautical miles and between 2,700 to 9,900 feet above and below the aircraft. TCAS detection ranges vary depending on your aircraft equipment. As soon as an intruder enters this detection range, the TCAS 2 provides display information to the pilot in order to help him to visually acquire the intruder. The proximate advisory volume is the first protected volume that an intruder enters. As in the previous volume, the TCAS 2 only provides display information to the pilot in order to help him to visually acquire the intruder. The traffic advisory volume is the second protected volume. As soon as an intruder enters this volume, the TCAS 2 provides oral warning and display information to the pilot in order to help him to visually acquire the intruder. The resolution advisory volume is the third protected volume. As soon as an intruder enters this volume, the TCAS 2 provides maneuver information to the pilot in order to avoid the intruder. The closest point of approach volume, in which the intruder must not enter. The estimated time before reaching the CPA is called TAU, time to intercept. In the array here below, you can see the relation between detection volume, intruder position, and displayed information. Note that TAU can also vary with the altitude. A control box located on the center pedestal allows the pilot to control the ATC and TCAS systems. The main part is dedicated to the transponder controls, while the right bottom part is used for the TCAS controls. The TCAS 2 information is displayed on both PFDs and NDs and on the engine warning display. We will now see a normal flight, which will enable us to study the TCAS controls and its indications. As you will see, we will encounter many kinds of intruder. During the cockpit preparation, the ATC panel has been configured. The TCAS has normally been set to standby, which is indicated by a TCAS standby green memo message on the engine warning display. In this mode, the TCAS is powered but not operative. Note: whatever the position of the TCAS mode selector is, if for any reasons the ATC selector is selected to standby or the altitude reporting switch is set to off, the TCAS will be in standby mode. The TCAS standby green memo message will be displayed on the engine warning display in the same way. We are about to take off. The standard operating procedure recommends to select TA mode in case of known nearby traffic which is in visual contact, at particular airports, and during particular procedures identified by an operator as having a significant potential for unwanted or inappropriate resolution advisories: closely spaced parallel runways, converging runways. For training purposes, we will assume that this is our case. Notice that the TCAS standby message has disappeared from the engine warning display, while the TA only indication has appeared at the bottom of both navigation displays. Proximate and TA intruders will be displayed, and all RAs will be converted into TAs. The all position of the traffic selector sets the vertical detection range to 2,700 feet above and below your aircraft. We can enhance the detection of the intruders, in particular during takeoff, by selecting the above position. Set traffic selector to above position. The upper detection range has now been increased up to 9,900 feet. Note that the lower detection range remains the same at minus 2,700 feet. Note: the use of this position is at the crew's discretion. We have taken off. During the after takeoff check, the standard operating procedure recommends to switch the TCAS to TA-RA mode. The TA only message has disappeared on both NDs. The TCAS is now able to issue RAs. For the cruise, we can reselect the all position. The TCAS is in its normal position for the rest of the flight. We are now ready to meet the intruders. In the rest of this course, the TCAS scenarios will be demonstrated via video clips. Each video clip will obey the following rules. Your aircraft is displayed in the foreground on a gray arrow which symbolizes its path. The TA volume front edge is symbolized by the amber area, the RA volume front edge by the red area, and the intruder is displayed in the background on a yellow arrow closing toward your aircraft. You are in cruise with autopilot engaged. The first intruder has no operating transponder. Please notice what will happen on the navigation display and primary flight display. You can notice that with this type of intruder, no detection is possible. You are in cruise with autopilot engaged. The second intruder is equipped with a Mode A transponder, no altitude reporting. As soon as the intruder is detected, a hollow white symbol is displayed on both NDs. Please notice what will happen on the ND and PFD. We will stop the demonstration each time the intruder enters a different volume. The symbol becomes solid when the intruder enters the PA volume.
Traffic, traffic.
When entering the TA volume, the symbol becomes an amber disc, and a traffic oral warning is triggered. No RA is issued when an intruder, equipped with a Mode A transponder, penetrates the RA volume. In this case, we only had information about intruder bearing and range. Note, the intruder may be well above or below your own altitude, and even out of the protected volumes, and therefore difficult to visually acquire. You are in flight with autopilot engaged. The third intruder is equipped with a Mode C or S transponder. For training purposes, we will consider that the ND has been set in plan mode, range 320 nautical miles. In this ND mode, the TCAS is not able to display traffic information. We will see what happens if an intruder penetrates the TA volume.
Traffic, traffic.
As the TCAS is not able to display an intruder in plan mode, when the intruder enters the TA volume, in addition to the traffic oral warning, the ND will show a TCAS change mode message. This message requests you to adjust the ND mode. Set ND to ARC mode. With an ND range set to a value greater than 40 nautical miles, the TCAS is not able to display traffic information. In consequence, the ND will show a TCAS reduce range message, requesting you to adjust the range setting. Note, TCAS change mode and TCAS reduce range messages can be displayed either in amber or in red, depending on the advisory level, TA or RA. If out of range, an intruder may be partially displayed. Set range to 10 nautical miles. The TA symbol is now displayed. A TA is not sufficient to initiate an avoidance maneuver. This symbol is here to help you visually acquire the intruder. For that, notice the figures beneath it. The two-digit number represents the relative altitude difference in hundreds of feet. These numbers are placed either above or below the symbol, according to the intruder's position. Here the intruder is 200 feet below your aircraft. When the intruder's vertical speed exceeds plus or minus 500 feet per minute, an arrow is displayed beside this symbol to represent its positive or negative vertical speed. Here, the intruder's vertical speed is below 500 feet per minute. Hereafter, you can see a few examples. These indications can be present for all types of symbols.
Climb, climb.
When entering the resolution advisory volume, the symbol becomes a red square. In this area, a resolution advisory, i.e. an order to react, is displayed on the primary flight display, vertical speed scale, associated with a customized oral order, here, climb, climb. When a resolution advisory is issued, the pilot flying has to disconnect the autopilot and fly the aircraft smoothly into the vertical speed green range. Here this will be done for you.
The PFD provides avoidance maneuver indications until the conflict is cleared. The green fly-to zone indicates the vertical speed range you should fly in to avoid collision. The red zone represents the forbidden vertical speed.
Adjust vertical speed. Adjust.
Clear of conflict.
The oral message, Adjust vertical speed, adjust, draws your attention to the vertical speed scale in case of a modification of the forbidden zone. You must remember that you are not obliged to maintain a set vertical speed, but rather to avoid the forbidden zone. So if you can reduce your vertical speed, do it. The clear of conflict message signals that the threat has disappeared and that you can resume your normal flight. In this case, we had information about intruder bearing, range and altitude, and instructions to avoid collision, oral and visual warnings.
You are in flight with autopilot engaged. The fourth intruder is equipped with TCAS-2 as you are. This time, TCAS-2 will provide a coordinated avoidance maneuver between both aircraft. We will play the complete scenario.
Traffic, traffic. Descend, descend.
Adjust vertical speed, adjust.
Clear of conflict.
The resolution advisory and its associated oral order, descend, descend, are customized to the threat. In this scenario, we have had information about intruder bearing, range and altitude, and instructions to avoid collision by a coordinated maneuver between both aircraft. For instance, when we had instructions to descend, the intruder had instructions to maintain level flight or to climb.
During the approach, the standard operating procedure recommends to switch the TCAS to TA mode. Note, this operating mode is also used in case of aircraft degraded performance, engine failure with landing gear extended, or visual conditions when flying in close proximity to other aircraft, or approach on parallel or converging runways, or at particular airports and during particular procedures having a significantly potential for unwanted or inappropriate RAs. Set TCAS to TA mode. As already seen, TA only is displayed on both NDs. Proximate and TA intruders are displayed, and all RAs are now converted into TAs. As we did for takeoff, we can improve the intruder detection, this time by using the below position. The lower detection range will now be increased to minus 9,900 feet. Note that the upper detection range remains the same at plus 2,700 feet. Set traffic selector to below. The below and the above positions can be used either in TA or TARA mode. The threat position will only display proximate and other intruders when at least one intruder is detected in the TA or RA volumes. Note, the use of these positions is at the crew's discretion. We have landed, and the standard operating procedure recommends during the after landing checklist to switch the TCAS to standby mode. The actions related to the normal operation of the TCAS are now completed. We will now see a brief summary of the different types of intruder. Look at the ND. We have seen all the different types of intruders you could meet. This is a demonstration of a traffic conflict, but this time the TCAS will not be able to track the intruder bearing. The intruder is equipped with TCAS-2. You are in cruise. Everything is normal.
Traffic, traffic.
When TCAS-2 is unable to track the bearing of the intruder, the symbol disappears, and information about the intruder is displayed at the bottom of the ND. Here we can read that the intruder is in a TA area. Its distance is 5.01 nautical miles. Its relative altitude is plus 100 feet, and its vertical speed is below 500 feet per minute. If the vertical speed had been above 500 feet per minute, a tiny arrow would have been displayed beside the relative altitude.
Descend, descend.
TCAS-2 is able to compute a TA or an RA without bearing information. Notice that the color coding of the type of advisory is respected. The crew will react in a normal way, following the advisory instructions. We will stop the demonstration here and see the indications if two intruders are threatening without bearing data. In this case, the TCAS is able to display data on both intruders at the bottom of the ND. We will continue by studying the advisory inhibitions. You are in descent. The closer you get to the ground, the more advisories are inhibited. An intruder declared on ground may reply to TCAS interrogations, producing unnecessary advisories. For this reason, the TCAS systematically eliminates responses from intruders below 380 feet above ground level, when own aircraft is below 1,700 feet above ground level. Radio altimeter input.
Below 1,450 feet above ground level in descent and below 1,100 feet in climb, the increase descent resolution advisory is inhibited.
Below 1,000 feet above ground level in approach, the descend resolution advisory is inhibited.
Below 900 feet in descent, the resolution advisories are converted into traffic advisories. All resolution advisories are inhibited. Below 400 feet in descent and 600 feet in climb, all traffic advisories are inhibited. Below 1,100 feet in climb, the resolution advisories are converted into traffic advisories. All resolution advisories are inhibited.
Below 1,200 feet above ground level at takeoff, the descend resolution advisory is inhibited. Let's now play with some intruders. In this module, we will illustrate different cases of traffic conflicts. Each time, the RA will be customized to the threat with adapted maneuver orders and oral warnings. You are in flight with autopilot engaged. In this presentation, you will see a climb advisory followed by an increase climb advisory.
Traffic, traffic.
Using bearing information displayed on the ND, try to visually acquire the intruder aircraft.
Climb, climb.
When the oral message sounds, within 5 seconds, you have to disconnect the autopilot and to react to the RA order. Corrective action.
Increase climb, increase climb.
Following a climb advisory, the increase climb oral message sounds when the first VS rate is insufficient to reach minimum vertical separation. You have to react within 2.5 seconds and fly into the new green arc. Additional corrective action.
Clear of conflict.
The TCAS was able to manage the threat and to request an increase of climb to maintain a safe separation. Note that you only have 2.5 seconds to react to the second order. We will now see another example. You are in flight with autopilot engaged. In this presentation, you will see a crossing climb advisory.
Traffic, traffic.
Using bearing information displayed on the ND, try to visually acquire the intruder aircraft.
Climb, crossing climb. Climb, crossing climb.
When the RL message sounds, within 5 seconds, you have to disconnect the autopilot and react to the RA order. Own flight path will cross through that of the intruder.
Adjust vertical speed. Adjust.
Clear of conflict.
In this demonstration, own flight path has crossed through that of the intruder. We will now see the next example.
You are in flight, climbing at 500 feet per minute with autopilot engaged. In this presentation, you will see a climb advisory, followed by a adjust vertical speed adjust advisory due to the presence of a second intruder.
Traffic, traffic.
Using bearing information displayed on the ND, try to visually acquire the intruder aircraft.
Climb, climb.
When the RL message sounds, within 5 seconds you have to disconnect the autopilot and react to the RA order.
Adjust vertical speed. Adjust.
Following a climb advisory, the adjust vertical speed adjust oral message sounds when the first vertical speed rate is too high to reach minimum vertical separation.
Adjust vertical speed. Adjust.
Clear of conflict.
In this demonstration, we have seen how the TCAS adapts the maneuvers when another threat is in the vicinity. We have studied climb examples. We will now see descent examples. You are in flight with autopilot engaged. In this presentation, you will see a descent advisory followed by an increased descent advisory.
Traffic, traffic.
Using bearing information displayed on the ND, try to visually acquire the intruder aircraft.
Descend, descend.
When the RL message sounds, within 5 seconds you have to disconnect the autopilot and to react to the RA order.
Increase descent, increase descent.
Following a descend advisory, the increase descent oral message sounds when the first VS rate is insufficient to reach the minimum vertical separation. You have to react within 2.5 seconds and fly into the modified green arc.
Adjust vertical speed. Adjust.
Clear of conflict.
Fairly obvious, isn't it? This demonstration of a descent is equivalent to the climb increase climb case. Let's go to the next example. You are in flight with autopilot engaged. In this presentation, you will see a crossing descent advisory.
Traffic, traffic.
Using bearing information displayed on the ND, try to visually acquire the intruder aircraft.
Descend, crossing descend. Descend, crossing descend.
When the RL message sounds, within 5 seconds, you have to disconnect the autopilot and to react to the RA order. Own flight path will cross through that of the intruder.
Adjust vertical speed. Adjust.
Clear of conflict.
In this demonstration too, the descent case is equivalent to the climb case. Let's study the next one.
You are in flight, in descent, at -500 feet per minute, with autopilot engaged. In this presentation, you will see a descend advisory, followed by an adjust vertical speed adjust advisory, due to a second intruder in the vicinity.
Traffic, traffic.
Using bearing information display on the ND, try to visually acquire the intruder aircraft.
Descend, descend.
When the RL message sounds, within 5 seconds you have to disconnect the autopilot and to react to the RA order.
Adjust vertical speed. Adjust. Adjust vertical speed. Adjust.
Clear of conflict.
Following a descend advisory, the adjust vertical speed adjust oral message sounds when the first vertical speed rate is too high to reach minimum vertical separation.
The TCAS manages the descent case in the same way as in climb. We have studied climb and descent examples. We will now work on slightly different cases, RAs with reversal of the vertical speed. Let's start by an initial descent case. You are in flight with autopilot engaged. In this presentation, you will see a descend advisory followed by a climb now advisory.
Traffic, traffic.
Using bearing information display on the ND, try to visually acquire the intruder aircraft.
Descend, crossing descend. Descend, crossing descend.
When the RL message sounds, within 5 seconds, you have to disconnect the autopilot and to react to the RA order.
Climb, climb now. Climb, climb now.
Following a descend advisory, the climb now RL message sounds when the TCAS-2 has determined that a reversal of vertical speed is needed to reach adequate separation. You have to react within 2.5 seconds.
Adjust vertical speed. Adjust.
Clear of conflict.
The TCAS-2 is able to react to a change of intruder behavior by adapting the RA orders. We will now study the same case, but with an initial climb. You are in flight with autopilot engaged. In this presentation, you will see a climb advisory followed by a descend now advisory.
Traffic, traffic.
Using bearing information displayed on the ND, try to visually acquire the intruder aircraft.
Climb, climb.
When the RL message sounds, within 5 seconds you have to disconnect the autopilot and to react to the RA order.
Descend. Descend now. Descend. Descend now.
Adjust vertical speed. Adjust.
Clear of conflict.
Following a climb advisory, the Descend to Now RL message sounds when the TCAS-2 has determined that a reversal of vertical speed is needed to reach adequate separation. You have to react within 2.5 seconds. The TCAS-2 reacts in the same way as in the previous example. In case of an in-flight TCAS failure, you will get a master caution and the following indications: engine warning display procedure, red flags on both PFDs and NDs. The TCAS is no longer operative, and TAs or RAs will no longer be issued. Notice that no system page is called. We have performed the procedure for you. The TCAS has been switched to standby mode. The status page is displayed for review. You can see in the Inoperative Systems column that the TCAS is now inoperative. We have cleared the status page for you. Notice the TCAS standby green memo message on the engine warning display. ECAM action completed. We will now see other cases of TCAS failure. This is a double radio altimeter fault. You will get a master caution, and on the engine warning display you can read the title of the failure. Notice the radio altimeter red flag on the PFD. The TCAS red flags have also appeared on the PFDs and on the NDs. Both RAs are faulty, which has led to a TCAS failure. We have cleared the procedure for you, and the status page is displayed for review. With both radio altimeters faulty, the TCAS is lost. Notice the TCAS standby memo message displayed on the engine warning display. The next case is a double ATC failure. Click on the forward arrow to carry on. A double ATC failure will also lead to a TCAS failure. As for the previous case, both TCAS red flags appear and the TCAS standby message is displayed on the engine warning display, whatever the selection on the TCAS mode selector. The two Mode S transponders fitted in your aircraft allow data exchange, altitude, identification, with the surrounding transponder-equipped intruders. Only one transponder is active at a time. The other is in standby. Both transponders are linked to the TCAS-2 computer. The top antenna and the bottom antenna are both used for transmitting and receiving. They serve to determine the bearing of the intruder located in the TCAS detection volume. The TCAS also receives inputs from the radio altimeters for radio heights below 2,500 feet and from ADIRs at higher altitudes. The TCAS-2 computer uses all these inputs to compute the intruder trajectories and provide signals to generate the appropriate intruder symbols on both NDs, avoidance maneuver orders on both PFD vertical speed scales, and the associated RL warnings. Only the 8 most threatening intruders are displayed. The FWCs generate priority orders between wind shear, stall, GPWS, and TCAS warnings. in case of wind shear, stall, or GPWS warnings. TCAS RL warnings are inhibited. All RAs are inhibited and converted into TAs. TA only message is displayed on both NDs.